Well, hi, good morning. Thanks so much for joining me in my shop here. It's March 30th today, and I'm starting on this battery operated. Well, I think it certainly is battery operated. Maybe could be plugged into Bradna, Bradna. It's the name of the radio. Whoops. There we go. How's that? Now that's a classic. That's a really classic looking. A little bit on the ugly side. Radio. Hey, what's this? Must be an antenna hidden up in behind here. Huh. Okay, and uh-oh. So that's volume. This is it's moving it. Oh, seems to slip a little bit here and there. Okay. Great. Now, I already popped the back off. It's a little hard to pop on, so I left it off. So, first thing, hey, where's the vacuum tubes? They're not in here. So, but I have a bunch. I'm pretty sure I'll have the tubes to fill this and get it going. Caution, remove supply cord before opening back. There's the supply cord hole. That's for batteries, but I did get a glimpse. Oh my gosh, look at that. It has a plug-in cord. Now that's unusual. It looks like there's a switch here. Probably switch it from battery to plug-in. Hey, that's fantastic. Okay, I can already see that there's an asbestos sheet right under here. I can see bits and pieces of it. Seeing bits and pieces of asbestos, not the best thing. Not the asbestos thing. Oh boy. So, it comes with this leather strap, I guess, to make sure you don't lose the back. And the schematic right here. Bradna portable radio. Licensed by the Canadian Radio Patents Limited. Patented 1927 to 1947. Inclusive. So this is probably just after the Second World War, I'm gonna guess. The Breadner Company. I've never heard of them. Breadner. Bread, like as in bread, as in toast. Breadner, N-E-R. Breadner. Some stuff here. Place battery in bottom compartment and insert plug. Move toggle switch to required position. Set should now operate when switch is turned on. That's the left-hand front control knob. Important. When set is out of use for periods over a month, remove the battery to prevent damage. Caution, do not remove or replace tubes while set is switched on. That's right, yeah, these tubes that are in here are low power tubes intended to run in battery sets. It is, so the heater is very, very fragile, and it's really easy to ruin these tubes if you do the wrong thing. And one thing you can do is pull it out. Now, why would pulling out a tube damage the rest of them? Let's see if we can see how they're wired here. So they're showing the heaters, like this one has a 500 ohm resistor in parallel with it. It's a little bit complicated wiring here. Oh, these are in series. Are they all? What's going on with this? This is the ground point. Maybe they're all in series here? It's worth figuring out right off the bat. And the power supply has a rough spot on the diagram. I'm not sure what would be there. That's a tiny capacitor. There's a 40, fairly big filter one here. There's the plug. That must be the switch that I spotted up here. DP, DT, double pole, double throw. So it's clearly, that's what this right here is. Switch on VC. VC. This symbol denotes a chassis connection. this symbol denotes a common negative. Are they not the same then? They must not be. So here we see to the chassis here. And we see the other symbol here, which is showing the common negative wire. So this has a common negative wire. Then this capacitor is just to drain the chassis back to it. Probably, oh no, some more connections here. Chassis to chassis. That's a connection there. Wow. Okay, I'm not going to study this in great detail. Just want to kind of get an overview of the situation. And how is the power being rectified in here? Is that what's missing right there? Selenium rectifier. Should be a rectifier picture right there. Is it scratched out by accident? Look at this. They nailed this piece of paper onto this board. There's the nails. Yeah, I think that's enough to get from here for now. Let's look at the actual condition of the radio. So I see a terminal strip here. Doesn't come through at all. That's, what is that? Oh, that's the wire. That's the wire there that goes out the front of the radio, loops up into the lid. So they put a terminal strip here. 2 wires going to it. Pretty loosey-goosey here. Okay. Not much else to see. This cord, clearly, I don't think it'd be wise to put a plug on the end of this cord and plug it in. Yeah. I think it's had its day. So we're going to want to take this radio out now. This whole board may come out, but that doesn't look like it. Looks like it's stuck in there pretty good. You can feel some screws under here. Two flathead screws. Not of the right type, really. These are the type of screw you countersink, into a hole. Not that it really matters. They did what they did back then. This is quite an annoyance. It's going to stay there, though. Yeah, the board, I don't think the board moves. Okay, see if we can get a little screwdriver in there. Okay, screws are out. Even my smaller screwdriver was still too big to fit in there. Okay. I think the knobs have got to come off. And we got to deal with this. Bring the radio and just kind of bring it out, or should we cut these wires off right now? That'll remove them from the antenna, and that'll disable the radio from being operated properly. It needs to have its own, not generic, its own antenna. So I think the name of the game here is to swing this out and set it down. Do you think they made these wires long enough for that? Probably flex there, but I have the feeling I need a little bench on my bench to do this. Oh my gosh, what have I got like that? Shouldn't take really very much. Put this here. That's almost enough to come onto here. Well, let's try it. We'll see what happens. bad. Okay, what do we get out of this? Hole in the speaker there. Another dirt here, maybe a little tear there, but good shape otherwise. Okay, I can't spin it around. Don't spin. Tempted to spin it around. Oh, well, I can maybe put this. Oh, what to do about that asbestos sheet first? That's in rough shape. Looks like whoever installed it just kind of tore it into the shape they wanted. And they just nailed it in. So I have two options here. One is just leave it and don't worry about it. Basically, if you leave these things alone, they leave you alone for the most part. Or I'm going to remove it. In doing that, I'm going to generate a bunch of dust, no doubt about it. I mean, this looks terrible. It's in there for fire protection in case there's a short in a component underneath the chassis. It won't spit fire or drip flaming wax onto this piece of wood and then set the whole thing on fire and then set your whole house on fire. That's what the asbestos is for. Messed up here. And this is like how did I get in there? This is a closed up unit. Well, hidden among the dust is going to be some asbestos particles, and frankly, I'm not too worried about it myself. But I think for now, I'll just leave that alone. So tip it sideways here, still. Get it up on the thing here. There we are. Okay, fantastic. I can tip this up if I wish. So, you can see this battery switch quite clearly now. It has marked on it very clearly, battery, AC. What did they put the word DC there for? That's a little confusing. AC, DC. Wow, battery. Okay, well, we'll leave it on AC. What's this? What's this doing here? There's another one. Wait a minute. There's three of them. Where'd these come from? Got a whole bunch of copper wire exposed on the ends. This one is going suspiciously. Well, I can't see it 100%, but I think it's going to the voice coil terminal on the speaker. Well, I don't know what those are. Two blue and a white. May have nothing. Maybe two blue doing something, and this white one for a external speaker. Who would do that to a little radio like this? It hasn't got any power at all, really. So this is the battery cable. Wires off here. There's some metal clip here hanging around. Brass clip. Maybe a clip that's supposed to hold this in the cabinet, you know, when it's not in the battery, plugged in the battery. It's a very unusual battery plug too. Look at it. Can't say I've ever seen one. Oh my gosh, what's going on with the camera here? I can't say I've ever seen one quite like that. You need a very specific battery to plug that into. Probably the batteries were where the money was. Selling batteries and tubes. Batteries and tubes. Okay, so I don't think there's any reason I can't flip this up this way. Away we go. Away we go. Well, there's a lot of stuffed in there. Okay, wild guess. These are replacements. But all the other wax capacitors are still in there. There's the rectifier, selenium rectifier, which is not so good. Here's a bunch of asbestos stuck here. Pull that out. I'm just going to throw it in my garbage can. I wanted to dispose of that asbestos sheet that's in the radio. The laws here, I've checked into it, it's considered an unimportant, non-industrial amount. You put it in 2 plastic bags, like 2 grocery store bags, and put it inside, double bag it, throw it in the regular garbage. That's how you deal with it. See, there's a piece of protective paper here. It goes all the way around, all the way up to here. Comes down here too. They've lined the whole inside with paper, which is kind of the opposite of asbestos. They're putting in some fire material here. We got to look at this with a close-up camera, though, to really get a good look at what's happening. Now, I think the automatic focus is on, so I'm gonna change that so it's not automatically focusing. You just bear with me for a second here. Just calling up the dialog box. Okay. Now the focus range is fixed. So I'll just start down here at the bottom of the radio. Cleveland condenser. That says 1 down there. Is it 1 or is it 0.1? 1. It's a biggie. It's a big one. Okay, we're just going to work our way up. Coil, resistors. That's a on-off switch there. Nice capacitor, not so nice capacitor. 0.05. It's pretty big. Built in Ottawa. There's a large resistor running up the back of the radio here. Here. This whole thing is one big resistor. Hey, there's those blue wires. One's on this terminal with a red wire going to it, right from a capacitor. So this is like a B+ wire. That looks like it was added in, not a factory thing. Well, this whole piece here was probably added in. This whole piece. Sprague Adams. Dry electrolytic. So one's going on the resistor here. It's not right on the end of the resistor. It's part way up. And it's probably suggesting that the negative common wire is running, the common wire is probably running a little bit negative to the chassis. Well, the chassis is tied in only by a capacitor, so I don't know. Just muttering along here while I do this. It's got a lot of writing on it. It's got writing on top of writing in there. Wow. It's got a band on both ends. Something peculiar about this particular capacitor? Don't think so. A lot of writing on it. take a good look at the rectifier here. So we're looking for curling on the plates. They don't look great. Like a surface that is curled off. I don't see it in there, or flaked off. But these guys are bad actors. Apparently, I've never had one do this, but the word is, one of these guys burns up, and it produces a stink so bad, wreck your house for like a month. Something like that, anyway. What's that way down in there? Can't really see it. Something there. What is that? Let me look with my eyeballs at it. That's not any better either. Oh, you know what that is? That's the bottom of the switch. That's the bottom of the switch in there. Okay, well, like, there has not been a conflagration, no crazy fire, nobody's come in here and cut all the parts out. Nothing really terrible has happened. It's pretty much the way it should be. Looks like a straightforward capacitor job. And, yeah, what's this big one doing here? 25 volts. So this looks like a big bypass capacitor. I'm going to go back and look at the schematic just a wee bit more. It's a biggie. Let's see if I can turn it and get the voltage on it here. Not the voltage, the rating. Type PRS. Pull it out. I'm going to be changing these out probably. Anyway, I mean, just need to get out of here. Come on. Reveal yourself. Oh, smokes. Okay, so under MFD, 250. That's got to be the voltage rating. That's got to be the 40's got to be the. What did they do here? They didn't print the rating on it. Oh, I got the whole cardboard part turning. It's stuck again. Well, pull it right out of here. Ripping it out. Well, it's got to be a 250 volt 40. I mean, it's got to be a 40. Look at the size of it. What are they doing with a 40? A 40 with 25 volts? What was the 25 over here then? DC working volts. 25. $250, $40. I don't know what's going on here. I'm not positive. I'm just not positive. It's only got one lead. I'm going to assume it's a bypass. We better look at that schematic again. Let's just take a look at the schematic. There's a 40 there and a 40 here. Now, there's a nut there. So here's the bypass. 200 MFD. Microfarad is what that must mean. 200 microfarads. Here. Well, the capacitor in there has 250 written on it. Is it a 250 microfarad capacitor? You know, it's a big honker. Wow, so that's a very large capacitor for using in a bypass situation, bypassing this resistor here. Wow, okay, well that explains what they are. We have a little bit of a grip. Yeah, now how is the grid bias done here? So the grid is blocked from the plate voltage here with that, and it's tied to the chassis through some resistors. A big one here, really big one here. yeah. It's getting its bias from this cathode bias system. So why? Let's go look at this grounding again. How they've done it. So it comes through the diode. It's just a little hard to look at here. How's this capacitor's in the circuit because it's in up here on the grid. Oh, I don't know what's going on. You flip the switch, double pole, double throw. How are they showing the switch here? They've got, so this is a double pole single throw here, and this is a double pole double throw. This is the on-off switch then. This must be the on-off switch, and this must be the battery selector switch. Okay, so that makes sense. So in the battery mode, you're flipped this way, but we're not going to be in the power mode, flip this way. So that connects this part of the line straight to the negative wire and through the capacitor to the chassis, to the common wire. I should call it the common wire. We follow the other way. We have just a half-wave rectifier here. I have to do some heavy filtering to clean it up then. So a 40 here with a 50. 40 and a 50. 2500. This is probably the long resistor. Is this thing here? That'd be only 3 terminals. The big resistor has looks like only 3 terminals. And one of them is very close to the end, so that would be the 50. Okay. Then we have the positive supply here. You're either getting it from the 7.5 volt battery, or wouldn't you get it from the 90? What's going on here? If you flip this way, 90 volts. Okay, 90 volt, and then if you flip it the other way, wow, I don't know. What are they doing here? So we have the B plus here coming along. Wait a minute. This can't be. Maybe I'm reading. Maybe this is the positive here. Okay. This. You know what? It can't be positive. Look at the capacitors here. The negative side is definitely to the wire. Yeah. Right. I don't know. Big positive voltage here. That doesn't make sense. You want the positive voltage here on this line. How's it going to get there? Right here. Oh, I see. It's taking it off here using the 1200. So I think what we're talking about here is you close the switch, you fire some voltage through here, finds its way to the plate here, and also probably all the other plates. Yeah. So we have these guys get their B plus supply from here through the 1200. Carry on with this. So how's this guy getting his plate here? He's got to get it. Getting it from the same place. Getting it from here. So what is this? It's, you know, it's a screen voltage, but it's not. Yeah, I don't get it. That's okay. I don't need to get it. Maybe you get it. I don't get it. Where's the volume control? Here's the volume control. Lots of action around the volume control to look at. So coming out of the volume control, you reach the blocking capacitor. It's blocking a little bit of DC that's developed here in this rectifier. And then the signal is shot to the grid to head to the audio signal. 1 meg volume control, 0.1 meg, 100,000 here. Now does that say MMF? MFD. They always write MFD every time. MFD. Oh, the draftsman should have done this again. This isn't a draftsman who drew this. Not a trained draftsman. Probably the junior technician in the factory in the back corner with a bad light drawing this diagram up, with the engineer poking him the whole time. So we were following, let's follow this heater situation now. 7.5 volts, that sounds like that's probably the heater voltage. It would come up here. Oh, that's what this is. This is a supply for the heaters? Right from here? They're taking it right out of out of here? Well, they can only get it from a couple of places. You can get it from a battery, but the batteries are not in. You got to get it from the power supply here, or there's an AC supply, which would be very commonly done in most radios. You have a transformer and an AC supply, or you put these things in series, and their voltage drop adds to the supply voltage. That's not what's going on here at all. So this is a manufactured feeding the heaters. This one next. Then this guy. Oh, what's happening here? 10 meg. Okay, so this guy, and then does it keep going past this connection point? I can't imagine. What's it doing in the volume control? For some reason, the current then goes this way and encounters this one, and then down to ground. So this line is at ground except for 500 ohms, and this thing in parallel. Well, I don't quite get this connection. That's okay. Don't have to know everything. So this 160 is a weird. That's why I think it says MMF. I think that's what that really says. This doesn't look like a MFD. So that'd be 160 picofarads. Very small capacitor. There's a little bit of a bigger one here. These are to the chassis. So you got this guy to the chassis, and then there's a huge resistor here. So there's a lot of pressure for the electricity to travel through this capacitor. So what you're doing here is you're draining the RF that's left in here. You're giving an RF ground. There's a couple ways of looking at it. You're chassis-izing the signal here. Why? And then you got this connected. I don't know. Once again, you don't have to know everything. Okay, but once you get to this side, you're a very high impedance circuit. Goes whips right through the antenna onto the grid, and there must be a connection point here. You can't see it, but there must be one there. So you're able to bias these two tubes with the DC generated here. And then this guy would act as a speed. Wow, you know what? There is no dot there. We don't know for sure what they're doing here, because we don't know if there should be a dot there or not. I don't see a dot. And this is the only tube that's controlled by AVC. That's possible. Okay, following out the audio here, gets a... What do they got going here? You got two grids. So the audio signal comes here. It's fed into this grid. This is an odd tube. And it looks like this is a screen of some sort. A screen with a great big resistor here. Once again, you don't have to know how it all works. So the audio gets amplified in here. We'll assume this is a screen. And then the signal, amplified signal, is then fed off to the grid here. And here we have a grid, screen, suppressor, and plate. No grounds on the speaker. Okay. Alignment on data sheet 4. 4748. Well, maybe while I ponder my next move with this radio, we might look into some interesting stuff I found in this book, the Everybody's Radio Manual, How to Build and Repair Radio Receivers. See the guy there? That's us. There he is. Look at him working away there. Wow. Now what happens if you have a couple of wires in your hand but you don't know the polarity of the wires? Well, this book shows some tests you can make to judge polarity. See those pictures? Down here it says testing for polarity. I'm just going to read this. It's not very long. This is for you and I when we don't know the polarity of some wires. Testing for polarity. Very often it is necessary to determine which of two wires carrying direct current is the positive terminal. This can be done in several ways. A voltmeter, of course, is the obvious test. However, if one is not available, attach a copper wire to each of the terminals of the current source and immerse the uninsulated ends in a glass containing water to which a small amount of salt has been added. Hold them about an inch apart. As the electric current passes through the water, it decomposes it. Bubbles of hydrogen will collect around one of the wires. This will indicate the negative terminal. So I got to get a little jar of salt water in here as one of my testing instruments. How about this? By soaking ordinary white blotting paper, everybody's got their blotting paper handy? Some blotting paper in a solution of salt water to which a few drops of phenolphthalein solution have been added. So you go to your kitchen and get your phenolphthalein. Regular test polarity paper can be made. The paper can then be allowed to dry and stored for future use. When the necessity of a polarity test arises, simply dampen the paper and touch the bare ends of the two test wires to it, as shown in figure 48. This is figure 48. There he is, the paper touching the wires. Red spot on the negative wire. Yeah, the area of the paper surrounding the negative wire will turn red. In another type of simple polarity test, a fresh slice of raw potato replaces the prepared test paper. When the two wires are touched to the white of the potato, a green spot will appear around the positive terminal. How do you like that? So there you are. That's the way to do it. Here's another one. This guy, I don't want to even read this one. He's testing a ground here. Look what he's doing. He's got a stake outside the house. Oh my gosh. Just doesn't look good to me. So, yeah, it's a lot better if you just use a meter. But I guess, you know, back in the day, there were people trying to do this stuff with nothing except a potato. How to fix your radio with a potato. Okay, that certainly cleared my head. Now I'm going to think about what to do with this radio, what steps to go through, and kind of come up with a plan of action here. Okay, so after giving it some thought, I think what I'll do is I'm going to restore the power cord and get rid of this rectifier. Put in a silicon diode in here, and basically and find tubes to put in the radio and get the radio ready for test operation as quickly as possible. I think that's the approach I want to take. But now I'm going to just take a minute because every 5 or 10 videos I've been doing a quick update on the COVID situation here where I live and in my province generally in Canada. So last time I spoke about this, it must have been a week and a half ago, I was saying my area was considered one of the hot spots. That's no longer the case. Hotspots are everywhere now, and what I'm talking about is the variants. So in Canada, the way it's different. We have a big country here, so there's many things going on differently in different areas. In my area, my province, the government is lifting the restrictions a little bit right now. At the same time, every medical or scientific voice that I hear, and there's a lot of them, are saying we should be doing the opposite right now, and that is locking down. We should lock down. The actual amount of sick people in our hospitals is, don't quote me on this, I'm sure you won't anyway, 20% higher than it was the last time we locked down to start a downturn. So numbers have been floating around pretty level. They came down like everywhere in the world, but now they've been going along level at a fairly high level, and it looks like they might be turning up. All the experts say, yeah, they're turning up. The line is coming up here, and it will soon just appear above. You have one round of infection going down and the other round of infection coming up, and it's superposition. You add those two together, and you get a flat line for a while, but then the downward one is done, and the upward one is left, and at that point, she shoots up. I think we're right on the cusp of that. So there's all that. Secondly, a report just came out. I don't know if it's a Canadian report or an international report. Points the finger at Canada as having done a terrible job, in fact the worst job of developed countries, maybe the worst job of any country in the world really, with long-term care and old folks in our old folks' homes. I think 70% of deaths took place in long-term care homes, something like that, a huge amount. I have the feeling there'll be a lot of political fallout from that. I imagine so. So the suspicion is the government here is trying to hold off on a lockdown until after Easter. The wisdom of that, there is no wisdom to that at all, except for political advantage. I don't mean to be political, but it seems kind of obvious that's what's going on, and it's going to backfire. I won't go into it any further. That's the situation here. Everybody tense, and I was vaccinated 2 weeks ago. So first shot anyway. That's the story. And now, just to finish that one off, across the street this morning, a crew is chopping a huge tree up in the backyard of my neighbor across the street, and I can sit and watch. And I was watching them. Nothing to do with the tree here. Back to COVID. One of them was smoking a cigarette. So I'm across the street in my house looking out the window. I could see the whole other house, the driveway, and there's a couple men standing there. One of them smoking a cigarette. And he puffed out, of course, right? And I could see the smoke travel as a pack rapidly right across the front of this guy's house and off, disappeared out of view, and by then it was starting to spread out. But for a while it traveled as a pack right across. It must have gone 20 feet, 20, 30 feet maybe, just like that. If you're standing in there and you inhale that smoke, that's the virus. That's the virus. Think about that now, If you can smell cigarette smoke, you can breathe the virus. Think of all the situations where you can smell somebody smoking cigarettes some distance from you. You can absorb the virus. That's what I believe. So, passing that along, just trying to tell everybody to look out, because all indications are the virus is just getting stronger, as it would. That's normally what happens. It gets stronger. Okay, enough of that. Now, what to do first? So I think to really get in here, I've got to remove this, get some space up in here so I can see what's going on. I can't see where the cord's coming in. It's all hidden up in here. So I'm going to take this guy out. It looks like it's nothing more than a screw and probably a nut on there. Oh, it's the loose as can be. That's not very good. I think you want this screwed down pretty tight in order to help with the conveyance of the heat into the chassis here. I think it's a little loose. I think it's going to run hotter. Maybe that's the first stage of the eventual conflagration. Oh, the unit itself must be threaded. There's no nut. Pull his guts out, man. Pull his guts out. There we are. Now these two blue wires, should I cut these away and just, you know, eliminate them from the scene here? They got hooked on something. What now? I mean, did somebody open up this radio and solder in these two blue wires and then close up the radio again? The blue wires, they're just coming out from under the chassis here. Well, that's not normal. Like this just isn't normal. What is somebody doing with these blue wires? That's worth figuring out. So, again, one of them clearly is on one of the terminals of this capacitor. So clearly this guy's carrying the B+. Oh, he's only soldered a couple of strands. I'm not going to have a B+ wire hanging out of here while I'm working on it. And they're not going anywhere. What would somebody have done with this? Hey, come on. Now the other one we could guess is going to the B-. Wow, it's way up in there. Like, how did somebody get their... Hey, where's my camera? Here it is here. Too dark in there. Okay, it looks like just a couple strands got soldered. Look at that thing. You can't look at it. I'm trying to look at it. Oh. Oh my gosh. Now what did he hook it up to? He hooked it up to the terminal. Has this many colored wire. Oh, disappears up the top. So he probably could have gone to the other end of this wire and found a much better place. Unless that's going to the speaker. I can't really see what it is. Can I just pull it out of there? Is it that badly soldered? Ooh. No. A little too much force on the radio there. I don't really want to stick a soldering iron way up there. Oh, there's next to nothing soldered here. Very hard to break solder or copper by bending it. I'm not bending it enough anyway. Got to get cutters up in there. We'll get rid of that piece of wire. I really want to get it right off that terminal. Oh my gosh, I don't think I can get in there. Something in there to cut. Nope. Nope. Got something. What did I cut? I cut this. Good. I cut anything else? Probably. No, everything looks okay. So that, you know what? That was off the back of the switch. That's what I'm cutting that off of. The back of that switch. Well, who knows what, without studying it. And now I can see this wire. And the crazy thing is, let me put it on the other camera. So out here, this is what it looks like. See the color of the plastic? But inside here, oh, it looks shiny and new. Is that really the wire there? That must be the wire. Yeah, that's the wire all right. And then it comes off of there. Looks like it connects to the switch here. Yeah, it looks like it goes around, picks up a terminal on the switch. I have to do the same. Now that's one wire. Where's the other one going? Where is the other one? They somehow... Oh, it's coming up to the rectifier here. Isn't that what it's doing? Yeah, it's coming up to this rectifier terminal here, which I can pull out and look at. Yeah. 2 wires on that terminal, 1 on this other. And now, oh good, a big plus sign. Now see how the coating, or whatever it is, the plating on this is missing all around the edges? I think that's the process of failure there, I think. Don't really know for sure. So I believe, you see, like there's a center column and then these plates sticking out. They're 2 different metals, I believe, sandwiched together under some pressure, and it results in a one-way valve action here. And the plates are sticking out here like this, I believe, for cooling, but don't quote me because I'm probably completely wrong about how this actually works. JB. Okay, it's coming out though. So I think I'm safe enough to cut it out and I have a good idea what's going on. Got a nice video of it in case I confuse myself. Of course that never happens. See if I can cut that whole terminal away and keep those wires connected there. I put an ohmmeter on this. I've never bothered testing these. I very seldom change them, in fact. Get my voltmeter here. Now the silicon rectifiers have a very high reverse resistance. I don't think these ones are quite so high. Like the ratio might be something stupid like 1 to 10 forward to back on these. I'm not sure. So, for what it's worth, what do we see? See, it looks like it's open this way. Turn it around. Okay, let's put away up on a much higher scale. 2 billion ohms. $1.5 million this way. $800. So the ratio here is terrible. It's 1 to 2. I thought 1 to 10 was bad. So would this qualify as a really bad rectifier? Well, I really think so. But wait a minute now. I'm using the ohm If I go down here and try the diode setting, the meter is supposed to tell us the voltage drop. I'm really not sure it's going to do it for this guy here. We're going to work on silicon diodes. Yeah, it's not going to work here. Okay, just for comparison, let me grab a diode here. Do the same thing with a 1N4007. I think that's a 1 amp. You know, that can handle 1 amp. You think this thing can handle 1 amp? I doubt it. Okay, so we're using the resistance scale first. Just a little bit of education here. So here we're seeing 165,000 ohms this way. And the other way, yeah, I think this is just going to put a lot of question marks in my head. So now, yep, she's reading open circuit this direction, even on 20 megohms. The voltage coming out here is a little different. If you put different scales on, you might see something different here. So open circuit, flip it around the other way. That's a 1,000 ohms there. That way. Let's go down in scale, see if we get a similar reading here. This is not really a terribly valid way of doing this. So let's see this. And I don't have any doubt that diode's fine. It's the test that I'm testing the test here. Okay, so now we'll use the actual diode test. Whistles on a short circuit. Okay, so now what my meter is telling me is there's a voltage drop here of 600 millivolts. Okay, we reverse the leads, and it's a perfectly good diode with a perfectly good voltage drop. For this one, okay, it's the wrong kind of diode for this tester. So I shouldn't even call it a diode. I think you should be calling this a rectifier. And it's just not going to show up at all. So I'm not sure what all that proves. Just like doing stuff like that now and then. Keep my imagination at bay by punching it out with real information. Now I got to pick a diode, put in there, and a few other things.